Hello, hello.
Testing. Okay, good.
Sorry for the slight delay. We had a network connectivity issue, but we are on now. So,
Yay.
welcome. I am Damian. This is
David Fowler.
David,
Yeah.
and we are from the ASP.NET team at Microsoft. Today we're going to do a talk on SignalR. A little bit different to the talks we've done in the past. We're kind of challenging ourselves, well, David's challenging himself really. I've got the easy job. To do something that we're not particularly familiar with, which will be fun, but we're going to use it as a teaching and learning exercise to hopefully let you walk away with a bit more information about how SignalR works under the covers and what has driven some of the recent expansion in how you can use SignalR, which is kind of cool, especially in these new sort of cloud-focused scenarios. So, very quick refresh on what SignalR is. I'm assuming, I shouldn't assume, but does everyone here know what SignalR is? Who has used SignalR before? Excellent.
Yes.
Okay. Well, we're going to do a quick refresh because it's been 6 years now. I think we've had a version of SignalR that's been shipped, but we've gone through two major revisions. We've got the sort of classic SignalR for ASP.NET, and then the ASP.NET Core SignalR, which came out a year and a half, 2 years ago.
2.1.
In 2.1. So, what is it? Well, we've kind of changed how we talk about it. We used to talk about incredibly simple real-time web for .NET, which I think I coined 6 years ago. But now, we've moved on. The industry is a little bit different. We care about other things. And so, what is SignalR? It's a framework for duplex RPC and streaming between client and server. There's lots of other RPC frameworks, like we added gRPC support in ASP.NET Core 3, but SignalR still has some unique capabilities, especially the server push element, which you don't get from things like gRPC, which is why it's still around. That's the real-time messaging bit and server push functionality that I talk about there. It also is built on top of a set of unique protocols that really form the basis of SignalR. In the original SignalR, there were protocols under the covers, but we didn't really talk about them. We didn't try and standardize them. We didn't really document them. They were just an implementation detail of the ASP.NET SignalR framework. Now that we're in more of a heterogeneous sort of embracing the heterogeneous world on the ASP.NET team, and we have Azure and we have services and all those type of things, we want SignalR to work with as many things as possible. And so we do have a couple of protocols. We'll talk about that. And that's what really allows SignalR to work these days. And then we have this server support for client addressing and grouping, and that's one of those things that really extends SignalR beyond your typical RPC framework, right? You have the ability to say, send a message to this individual client, or to group a series of clients into a group that you call them and send them a message. You don't get that with a typical point-to-point RPC framework. So, very quick demo. Here's, a classic SignalR app, a chatter app, Chatr. All SignalR apps have to have their last vowel removed in order to make them a SignalR app. So I'm going to boot this one up, and it just looks like the standard sort of chat app you would have seen we demo for SignalR for a while. Your browser is downloading a proxy script, which I'm very happy to see. Oh. That's awesome. So I can type in here and hit send, and it sends and comes back from the server, all the type of normal stuff that you would see. And I've got this other button over here, stream, which utilizes a new feature in SignalR in ASP.NET Core, and I can click that, and then the server is streaming information down to me. It's going to count up to 10 in this case. Now, we were able to do things like this before in SignalR, but because of ASP.NET Core, we have some new... Why is your output window stuck there? That's super interesting. I'm using David's laptop, so if I feel like I'm clunking around a bit, that's why. So let's have a look at the server code so we can all remember and refresh ourselves what this looks like. Here's the really simple part, right? The send message on the server is just in a hub. I turn around and say clients.all.sendAsync, and that's all I have to do. The stream one is the new one, so I'm now taking advantage of... You have turned off tap, haven't you?
What? Yeah,
like a terrorist. Okay. All right. That's why I'm struggling so much. That's why I couldn't close anything. We're using the C#8 iAsync enumerable or async streams feature in order to very simply allow a client to call the server and then us stream information back with a beautiful awaiting yielding for loop right there. Like doing that type of stuff previously required you to use extra frameworks or other type of primitives. Now that stuff is all kind of built in. What does it look like in the client? It's all pretty straightforward as long as you're happy and comfortable doing JavaScript. That is the wrong file. That's the C# file. So, we've seen this type of stuff before. I've got a bunch of JavaScript. I create a connection up here on line 35. I'm configuring some logging so we can see some stuff take place. I'm going to grab my chat form, wire up an event listener, check some validity. I actually used like HTML5 validation and stuff in here, which is kind of cool. And then I go ahead and I do some DOM stuff. Like this is all very, very standard type of stuff that you would have seen when doing any type of client development. I'm not using any frameworks. This is just bare bones to sort of see how this stuff works. So that's our super quick refresher on how SignalR works. That's all we really need to get back to in our level of understanding to understand what we're going to do next. So we've all seen in the past how SignalR supports multiple clients. I showed you the JavaScript client just there. We also support different transports, so I'm using WebSockets, but as we've had forever, we fall back to other transports like service and events and long polling in the cases that we can't do that. And we ship a bunch of client SDKs. We ship the JavaScript SDK, the .NET SDK, the Java SDK. There is a Swift SDK that's third party. There's a Python SDK, and we are currently writing a C++ SDK. So we've got all this nice support on the client and transport. So what is it that makes that possible? Well, I mentioned it before. We have these protocols. So this flexibility is enabled by two layers. We have a transport protocol layer, which, as you can imagine, defines the set of rules that say, well, a client wants to connect to a server over some type of transport. Okay? The default one that you're usually used to is HTTP. But you can plug in your own transports if you wish to. And there's a link to a spec there. You can go up onto our GitHub site and you can read the protocol spec for the transport. And then the second layer is the hub protocol, and that's the messaging protocol that SignalR uses to support the fact that the client can call a method on the server, and that the server can call methods on the client. And that gives you all the message types that you would expect in any type of protocol. So for transports, we've all seen these type of diagrams before. The client connects to the server with long polling, and then the server is going to wait for an event to take place, send that response back, and then the client will send another request. For service and events, which is one of our fallback transports as well, the client will send a request to the server turns around and then pumps messages down over that event source object stream back to the client, and we can get messages that way. And WebSockets is the one that we really want to use, right? If we're in the browser, we do a WebSocket request to the server says, yep, that sounds great, let me send you back a 101 and we'll switch protocols, and then we can just happily send messages to each other over that existing TCP connection. Wonderful. The very first request that gets sent is a negotiate request. Before any of the messages start flowing, the client and the server have to agree on what transport they're going to use and what protocol, messaging protocol they're going to use. And so we send up a negotiate request, post some endpoint with a negotiate path, and optionally sending a negotiate version. And then the server will respond with a response with a bunch of metadata, like a connection token and an ID. What version are we negotiating with? And then a list of transports that the server supports. Okay, and then the client can use that information then to actually make a connection to the server. Here are the types of messages that are in our messaging protocol. So this is all the types of messages that are required for a server to support a client talking to it with hubs. You don't need to know these. You can go up to GitHub and read the spec. But if you're going to build a server, like we're going to today, you'll need to understand these different type of messages so that you can set up a compliant server so clients can connect to you. So why don't we build a server? Because, I mean, we can show slides all day, but I want David to feel uncomfortable on stage. So I'm going to make him write a server in something other than a .NET language. All right. So you're going to use Go. You know how to program in Go, right?
Nope.
Okay.
Does anyone here know Go? Who knows Go?
Does anyone know? So no one's going to be able to call him out.
Anyone can do this. Like you guys kind of, yeah. So
all right.
I probably learned Go over the last couple of months. I don't super know it very well. But I know it more than you guys, so it's good enough, right?
As long as you know more than anyone in the room, we'll be totally
It's good enough.
fine.
All right, so let's do a Hello World Go just to get everyone's feet wet and warm. Wet, warm?
Warm and wet.
All right, let's, in the same folder, I'll do let's make their dry run. In this folder, I'll open VS Code. Yeah. Code supports every language pretty much on the planet.
Language, right?
So I'll type in a main.go here. Here's my empty file. Right, easy so far. I'll create a package. This is like an assembly boundary basically. Package main. Here's my main function. Isn't doing very much right now. I'm gonna print hello world. So fmt.println hello world. Pretty simple. So imports are, so for .NET developers, imports are like usings. I want to import a namespace.
Okay.
FMT is the package name.
Okay.
FMT has a method called printLine on it. I'm calling print, and I'm printing hello world.
Okay.
Pretty simple, right? On the shell, I can go run main. I should print hello world, right?
That was quick.
Simple. Awesome.
All right, we're Go developers now.
Woo!
Excellent. Yeah. If nothing else, you can walk out today saying you've now know how to do Hello World and Go.
All right, so that was lame. Okay, let's do hello world HTTP.
So I can connect to that with SignalR now, right?
No.
No, okay.
So there's a package called HTTP in Go framework, in Go BCL. And there's an HTTP package where I can call methods like listen and serve, which will listen on a port and address. I can say listen on localhost 8085, because that's very specific for a reason. Haha. And I can, so far this does nothing, right? I can actually listen to, add code for a specific endpoint.
Okay.
So I want to handle func, slash, and I want this to return hello world. I'm going to do an anonymous function.
Okay.
And there's no type inference in Go, so I have to actually remember this. It is W is a HTTP dot response writer, and request is a pointer of HTTP dot request, not read request. All right, good so far. All right, now I'm going to print hello world. So write W dot write. Something's broken. This should be like that. This should probably not be there. All right, better. Write hello world, and it won't work because this is it's expecting a byte array. This wants a byte array, and I'm passing it, or a byte slice, and I'm passing it a string.
String, right?
But in Go, strings are bytes, so I can just cast it.
Oh, nice.
That should just work. Huh?
Cast it to a string.
Oh, wait, other way around, byte array.
Right.
I can cast this to a byte array. And in Go, everything's backwards, so this is an array of bytes.
Well, yeah, I was like, even your type
Array
declarations
of
in your
bytes.
Lambda are backwards to what I'm used to as well.
It's forwards, because you're like, it's English. You're saying W is a response writer,
Okay.
request is a pointer to a request.
Okay, so it's like VB all over again.
Oh, I mean, yeah. So if I hit port 8085,
All right. Okay, so we've got two Hello Worlds.
let a server and Go.
We're closer to connecting with the SignalR client at this point.
Yeah.
We have an HTTP endpoint. All right.
First step is to get your application into my application. So you wrote this thing called Chatter,
Yes.
and it was in a folder called Chatter, and
Yes.
a folder called www.
Yes.
I'm gonna copy all of it over to here.
Okay.
So now I have your entire
Ah, there you go. You got all my stuff.
thing. Let's rename this to index,
Okay.
and then tell Go to serve static files from www.
Okay.
So I can do, by the way, I have a script. I'm gonna copy and paste from at some point. I'm just like going from my brain right now.
Okay.
So handle slash, and I want to handle all files, so file server, and http.dir. So I'm saying handle serve files from this folder. So here's that folder, .root.
So the file server method is returning a handler,
Yep.
basically, and then that's being passed.
So handle takes a path and a handler. A handler is an interface that has a method called serve.
Yep.
Serve takes in a request and a response, and you can write
So it's
data.
like our request.
It's like a request handler in
middleware.
ASP.NET Core.
Yep.
It's like
Okay.
middleware. And file server implements the serve interface.
Yep.
And it gives you a way to specify a directory to serve files from.
Makes sense?
Right. So now I should run this again, and I should see
My,
Damian's beautiful UI that he
beautiful
spent
bootstrap
way
page.
too much time trying to make it work.
hey, it's got to be pretty for the people.
But in Go,
All
if
right.
I hit the actual networking stack now, and I hit, look at the console.
There's lots of errors.
Yeah, so it requested the negotiate endpoint, and then it said couldn't find it. Makes
Okay.
sense, right? I don't have a negotiate endpoint.
So we're basically at the first point. My JavaScript code is running. I showed you before. Signal is trying to make a connection.
Yep.
It's making the negotiate request.
Yep.
I'm getting a 404.
Yep.
Because all you've done so far is write an HTML page.
Yeah.
Or copy my HTML page, actually.
Yes, copied.
So
I'm building on your
the
previous
first
success.
step in getting the protocol to work
Yep.
is you need to negotiate endpoint.
That's correct. So looking at the full protocol, so here's the actual link to the website that has our protocol description, and it describes what a transport protocol should have. It has to be full duplex, has to be binary safe, has to be text safe. Describes the negotiate endpoint, the responses for version 1 versus version 0. So we're going to implement a version 0 response because I'm lazy.
You're lazy.
Yeah.
Who has ever like implemented a protocol before? Like, look, they had to read an RFC or read some protocol and they've written code to implement it. Like a few hands? Oh, no, that's a few people. That's good. Okay.
So I want more clients for SignalR.
If you want something fun to do, go and try and implement ours and then give us feedback as if it's any good. Like maybe we need to improve our protocol.
It's perfect.
It's perfect.
Yeah.
Okay. I will let them be the judge of that based on how well you go in the next half an hour.
So I'm going to create a function called map_hub to map my hub, and to not write the thing in reverse, it's a path where path is a string.
Okay.
Okay, path is a string. And I need to handle the negotiate method first. So time to start copy pasta.
Okay. Negotiate always goes to /negotiate. That's hard coded.
It is.
Okay.
And I believe I have this thing in talk. Wait, snippets. All right. Haha, I see. Don't look at my cheat sheet. don't look. Okay. Map hub, pretty simple. Doesn't do much. Here's negotiate. I need to copy the actual structs. So in Go, structs are actual structs. They're value types. They live on the stack. So I'm declaring 2 structs here that will store my negotiate response.
Okay.
And these tags over here are the attributes. So these are like JSON name is transport lowercase t.
Okay.
And JSON name here is also lowercase transport formats. And then you can also add things like, I want to omit this field if it's null, for example. So this is basically an attribute in C#. So think of this as like this other stuff that can be read out reflection time.
Got it. It's just metadata.
Yeah.
Just metadata.
Yep.
A special comment.
Yep. It's pretty gross. I love Go.
Tell us what you really think while you keep doing this. This is good.
So that's fine. Now we have to actually like handle the negotiate method. So map_hub will take the string in to the path base of the actual SignalR connection.
Okay.
So the SignalR hub. So chat is the actual like hub.
Okay.
And here's my negotiate handler, which is
So it'll be
nothing
like
right now.
/chat/negotiate.
Right.
That's where this is going.
So if you look at the actual error, it should have said /chat/negotiate right here.
Yep. Okay. Got it.
Makes sense. All right. So let's copy paste this negotiate handler, so we can have a ton of time to explain it. All right. So what did we just do? We copied a bunch of things from my snippets. The first thing is it expects a post, not a get or a put or option or whatever.
Yep.
So if you're not post, return a 400. It's a bad client. Client's doing bad things, right?
Any particular reason we want to post instead of a get?
No.
Okay. All right. That's fine.
I think it was because we want to
thing,
plan for sending a body at some point, maybe.
Ah, okay.
I think we had a body in the first version and we removed it, so
Okay.
reasons. The connection ID can be anything. We generate a random crypto hash for security reasons.
This is the connection ID?
Yep.
Okay.
So the ID, this will identify your connections for future usage. Like I want to talk to that connection. So this ID is actually gen from the server side.
And the protocol doesn't specify the format. It can be anything?
It can be anything.
It's just an opaque string?
That's right.
Okay.
So get connection ID will just base64 encode a randomly generated byte array.
Okay.
So this is the Go version of new crypto random, like generate random bytes.
Okay.
Base64 encode that byte array into a string. And then we send a JSON response that maps to this struct. So this is the equivalent of doing new negotiate response, setting properties, setting fields, and then setting values, and just returning a giant array. Makes sense, right? This looks good so far.
Right.
Simple. All right, let's see what our server does now. So now I have a negotiate endpoint. I'll rerun Go. And in Edgeium, does anyone here use Edgeium? I mean Edge.
New Edge?
New Edge.
What are we supposed to call it? We should have looked at the marketing material before we came.
Edgeium, make it a thing. Edgeium.
Credge is the other one I've heard.
Credge is so bad though. Okay.
All right. So I see more success this time.
Perfect.
Okay.
More white, less red. So negotiate responded with a beautiful JSON response. We can see it got responded here. Transport WebSockets, transfer formats, text binary. Transfer formats basically let you know if the transport supports text or binary. I mean, it's pretty obvious here.
So that's also new in ASP.NET Core SignalR, is we now support binary message types. And so the transport has to say, yes, I can do binary.
I mean, you only have that because server-sent events did not support binary, so.
We have to be able to tell you whether we do it or not.
Yeah. But it tried to connect to the chat endpoint with the WebSocket hand request, and it gave a 404.
Okay, so we've gotten through negotiate now,
Yep.
and then the next step is the client wants to say, yep, I'm ready to send you a WebSocket because you said I could use WebSockets.
Yep.
So it created a WebSocket connection, but that horribly failed because you haven't written any WebSocket code yet. Okay.
So let's add some more code now. So let's kill this server.
All right.
Copy pasta. In map public, I'm going to add some code to handle a WebSocket connection.
Is that built into the HTTP package you were using already? They have a WebSocket thing?
It is. So there is a WebSocket package as well that is separate.
Okay.
They actually recommend using a third-party package because the one built in is apparently not good.
Oh, okay. You're using the built-in one?
Yeah,
okay.
Of course. So, so I added a handler for the chat, the hub endpoint.
Okay.
And WebSocket.handler returns a handler instance that implements the handler interface.
Yep.
Gives me a WebSocket connection, which I can actually get stuff from the request and response from. So if you had negotiated from the client side, so the client can do negotiate, get an ID back, and then connect with that ID to WebSockets.
Okay, so if I have an ID, I'm going to send that up on my WebSocket connection and pass the ID.
In the query string.
In the query string.
Yep.
And then the server, I'm assuming, would usually validate that and say, yes, that was the ID I created for you.
This is also why SignalR requires sticky sessions in core, because you have to have had the ID come from this server.
It's stateful.
It's stateful in that sense.
Okay.
That request.
For some period of time. Anyway.
Yes. Yeah. There's also a feature in SignalR where you can do a negotiate list connection. You can connect with an endpoint directly from the client side to WebSockets, and we'll just work from there.
So why did we bother with doing negotiate?
Because by default, it negotiates, because it wants to support falling back to other transports if the server, if the client doesn't know where it's going to run, the client has to be able to negotiate and fall back to other transports.
Okay, so the modern SignalR server does support doing like a single request connection thing where you don't have to negotiate first if you just both, YOLO, I'm going to use WebSockets.
Because I know.
Because I know.
It'll work.
Where do I get my ID from if I don't negotiate?
So the code's right here. So the code says, get the ID from the query string. If it's empty, just gen 1.
Oh, okay. Cool.
Right. Okay. All good. In the client side, there's an option called skip negotiate. If you make it true, it just does the actual direct request.
Nice. Okay.
Yep. But if you configure skip negotiate, you have to say WebSockets only.
Fair enough.
So you can't do skip negotiate.
Because WebSockets is the only one that
supports
has
the direct
one connection, so you don't need to correlate with an ID.
That's right.
Okay.
So here's our WebSocket handler now. Now we should be good to go, right? This should work. Boom.
All right, so you have a WebSocket endpoint now, so we would expect to see the WebSocket request succeed.
Less red, more white.
Okay.
Yeah.
This is less red.
Okay, so it connected via WebSockets. It was happy. It sent the handshake. There's a handshake that goes from client to server.
Okay.
It chose the JSON protocol because that's the default protocol. Then it died completely because the Go server actually wants you to keep this function around until the socket is dead. So if it does nothing, it'll just kill the whole connection immediately.
Oh, okay.
So you have to start reading from the actual socket once you have booted up that connection. So I have to write a for loop in here. So I'll just keep copy pasting because it's probably easier. I know, right? So here's the handshake request that we get from the client side.
Oh, so okay. So the socket was established.
Yep.
And the very next step is someone's going to send a message.
That's right.
Which end is sending the message?
The client.
The client will send a special message, a handshake message.
Right.
That's a SignalR message type.
Right.
And that's part of our transport spec or part of the hub?
Oh, good. It's fantastic. So we went from transport protocol spec, where we went from not having connection to having one. Once we have one, you flip into the hub protocol spec.
So now we're in the hub protocol and we're doing hub speak.
Right. And the hub protocol is about invocations and streaming.
But we first have to negotiate
the actual transport.
Within the hub protocol, and that's what the handshake's for.
So the very first thing in the hub protocol is a handshake request.
Okay, got
it. The client sends a handshake saying, I can do JSON version 1. And the server says, no, stop, or yes, that's cool.
Okay.
And it sends a handshake response. So if we very temporarily print out what happens, let's just do that. So in Go, there's no while true. There's no while loops. There's no do while. There's no for
so you do like an empty for?
There's a for. There's just one loop type. Yeah, who knows why.
Okay.
WebSocket.message. I'm going to read a message off the WebSocket, off the wire. I'll declare a data array of bytes, slice of bytes, receive data, and then error handling in Go is kind of jank. So you end up having to write code like this a lot. get a thing that has an error. There's no exceptions, so nothing throws and blows up in your face. It's kind of nice.
Okay.
Also, when you save, go format runs, and this formats your code, just destroys it.
Very opinionated.
It's good. No, it's good. It's good. It's good. Why is it doing that? Oh, it's killing me. What? Huh? Wait, hold on. There's something wrong here.
You got if error at the end instead of just error is not equal to.
Oh, that's why. Okay, good. Let me just print this. So fmt.print line.
Okay, so you're receiving a message, and if there was an error, then you print it on the server side.
And break. Yep.
And break out. Okay.
And then I'm going to print the actual data from the client to server. So whatever I receive, I'll print on the console.
Okay.
So received, colon, then I'll just cast to a string because that's cool. Assume all bytes are strings is how we do encodings.
I expect to see some wingdings as a result.
Oh, that's JSON. It should work. All right, so at this point, I can just refresh. I should get the same.
Ooh. There's no red.
But there's no more white.
That's interesting.
So the server received the protocol. There's the handshake. Protocol JSON version 1. We're good to go. Okay. So now we should parse the protocol, assume it's good, because this code is perfect.
So if this is a handshake, doesn't the client expect you to shake back?
To respond? Yes.
Isn't that the whole point of a handshake? Like right now I've done this, and you're just leaving me hanging.
I know. It's kind of embarrassing, I guess. So we're going to copy this giant process handshake function.
Did it fail eventually?
Yeah.
Oh, so
yeah.
Why did it? Okay, so it did.
So it timed out.
It timed out.
Yeah.
Okay. So the client, I did this, and then after 5 seconds, I was
on.
like, screw you.
Yeah, the client's like, okay, I'll just.
All right.
I guess no one's there.
All right.
Doorbell, no one's home.
No one's home.
Tap out.
Okay.
So I'm going to copy this process handshake function, which very naively parses the handshake. SignalR protocol, let's actually look at the protocol in a different browser. I love Edgium, but there's a bug. There's a bug in the new Chrome that I verified with the actual Chromium team, so it's not Edgium's fault.
Oh, really?
Yeah. Where the WebSocket inspector only shows one frame.
Oh.
Oops.
So as long as what you want is in the first message, you're fine.
Good to go.
Okay.
I'm on the bleeding edge bits of Edgium. That's why it didn't work. What's going on? Oh, my server's still running. Run this again. So you can actually see the data being sent over the WebSocket
connection.
There it is.
There it is.
I guess I only sent one thing, but see this block? This super strange block?
That's my wingding. You came through. It's awesome.
So every SignalR message in the JSON protocol is terminated by it's called a record separator.
A what?
Record separator.
Record separator.
Yeah, it's
okay.
ASCII code 30.
Okay.
We chose it because we needed to have a protocol that wasn't bound to a specific transport. We could have said every single message in SignalR is bound to the WebSocket message. That would have been easier.
I see.
But to make it hard for ourselves, we wanted to have our own format that can last across multiple transports.
Okay.
So if you're on TCP, there's no framing. So how do you find the actual end of a message if you don't have framing?
We need to know this is the end.
This is the end of the message.
SignalR message.
Yeah. Okay. Which means you could have more than one frame that isn't a full message until you see this actual.
And we didn't want to use carriage returns or line feeds.
It had to be a thing that was JSON safe.
Had to be
so
JSON
you can't put this in JSON.
Okay.
We found the one thing you couldn't put in JSON.
Okay.
Perfect. All right, so let's process the handshake. So here's a response. Here's the handshake parsing. Because we're super naive, we're going to assume that whatever gets sent, that the first thing that gets sent is the actual protocol, the handshake request. And we won't even loop. We'll just assume it's there.
Is that actually naive, or is that perfectly legitimate? Isn't that what you would expect?
If the client sent a single byte at a time,
oh, I see.
It would break. But who does that? Who does that?
Who would do that?
Yeah.
A malicious client.
Maybe.
Okay.
So this code assumes that the thing that I got has a full message.
Well, had a full message.
Because I'm lazy. So
I got it. I see.
I get a payload, and then I look for the 30, which is the actual record separator.
Okay.
I slice. Here's a slice operation. You can just like say, get index and end. So unmarshal is deserialize. So I allocate a struct. I deserialize the payload into that struct. And if there was an error,
is the word serialize and deserialize a .NET-ism? Or does everyone say that?
I think on Java does deserialize.
Java? Okay.
Yeah.
Because unmarshal sounds
I've seen parse,
different.
Stringify, marshal, unmarshal. It sounds more low level. It sounds more like I'm coding.
Sounds scary.
I'm coding super hard.
Unmarshal.
Marshall.
All right.
Marshall, unmarshal. If the protocol isn't JSON, I'm going to return an error response to the client side.
Okay.
And assuming it is JSON, we're all good.
Okay.
So I'm going to run.
Send the handshake response. Okay.
Yep. So I'm going to run this first and just say error equals process handshake, WebSocket, assume the handshake is good. And if, like every piece of Go code on the planet, if error is not equal to nil, just awful. Just, ugh. Return and print, because in case I want to see the error, let's print it. Okay, let's go. This should work now. We should have way less red.
So in theory now we'll be able to leave it open and it won't time out. It'll just, we've done our handshake and now we're waiting for something else to happen. How many seconds do we have to wait to be guaranteed that we're
Success!
Good?
It worked.
Oh, okay, server handshake complete. All right, okay, handshake's good, we're done.
Okay. Ooh.
So can I, all right, make it fail again.
What did
do
it
something
do?
else.
What did it do?
Do something more.
Let's look at the actual socket. The socket said, where's the socket? There it is.
Okay.
Oh no, I'm not edgy. I'm not Chrome. That's the bug, by the way. See, it returns a response.
Ah, okay, so green means client going to server, and red is server
to
coming
client.
back,
Yep.
right? Okay. And so the server sent back an empty JSON object, which is the handshake being completed.
Yep.
Okay. All right. Oh, what's that?
Interesting.
So the client just tried to like do something.
Yeah.
What is it doing?
Let's find out. So when you're lost, you just search for type.
Oh, so we're back in the spec. Okay.
Type 6.
It's a ping.
A ping. So the client and server send pings back and forth to make sure that the other party is there, right?
So this was the client because it was green.
Yep.
So it was
the
going
client sent a ping to the server side.
Okay.
And if we're lucky, it sent 2 pings.
Ooh.
And at some point, it gets angry and says, you know what? You aren't pinging me. You're offline.
Okay. So SignalR includes a ping pong kind of thing, basically.
It's not pongs, just pings.
Just pings. But is it only client to server, or does the server send a ping as well? In a good server, not your server.
Yeah, and the good server, it sends pings both directions.
Okay. And so the client is basically trying to make sure that the connection is actually alive, because you can never trust what your connection API is telling you.
You go through a tunnel.
The health of your connection.
You go up on a plane.
Yep.
You fly through, I don't know, like...
Fly through a tunnel?
A black hole.
Okay. All right.
SignalR works in black holes.
So once the 2 pings basically don't get a reply, the client says, nope, this connection is no good.
And it isn't just pings, it's any message. So
any
pings
message.
only get sent if things haven't been sent in that time frame.
Okay. All right. So we need to get the server to respond to
All right,
pings.
let's add some pings.
All right.
We need to add our own pinging. Let's do that. Here's pings. Here's my super fancy ping logic. Here.
What's the ping timer? What's the timing it expects? How many seconds? Some? Does the protocol specify it?
It's in the code somewhere. No.
Oh, okay.
The client decides when to die based on a threshold. I think our default is like, if you haven't seen at least 2 pings in like 30 seconds.
Okay. 2 in 30 seconds, and okay, that's the default. But can you configure it?
Yeah, you can. Okay. We tried more aggressive numbers, and it kind of broke people, so we kind of went conservative by default. So it dies at some point, but it's not super aggressive.
Okay.
But you can tweak it to be whatever you want on the client side. So here's a pinger. So in .NET, you'd create a new timer. New timer has a callback. That gets callback every whatever seconds you passed into it. In the callback, you would just like do something there, right?
Right.
Super simple-ish until you learn how it works.
Right.
This is the Go version. You create a ticker. And in Go, there aren't that many primitives. So the pattern you see a lot is channels. So a channel is basically, think of it as an async enumerable you can actually read from or write into.
Okay.
So I create a ticker. I'm going to run every 10 seconds. And I made a channel of bool. Just don't ask why this is here yet. Here's an infinite loop. And it says whenever the ticker fires, run this callback. So I'm switch casing over the actual channel firing or done being set.
Okay.
And I fire an anonymous Go routine inline. This is task.run callback.
Go.
Yeah, this is task run and go.
Okay.
And ticker is basically a wait for each. Have you guys seen the async enumerable pattern in C#?
Yeah, well, I showed it in the chat app.
Very
briefly
await
before,
for each.
Right?
This is the equivalent of await for each tick in ticker.
Okay.
Right? This code does that.
Okay.
All right.
I'll take your word for it because no one in here knows Go.
It's perfect. No one can call me out. All right, at the end, ticker.stop, and I'm going to write a bool into the done channel, which is super, super janky syntax. You're putting something into the channel. That's what you're doing.
From right to left?
Yeah.
Okay.
So if the channel is on this side, you're reading from it.
This side being what side?
The right.
They're looking at it this way?
The right. I'm putting true into done.
Okay.
Pushing it in.
Okay.
The arrow is literally like forcing it in.
Okay.
All right. So now, this should give me a stable connection.
A stable one, hey?
So this should not time out.
Okay.
So let's look at Chrome and just stare for like half an hour.
I'm having deja vu. I think last year we had a SignalR demo.
I don't recall that.
And we spent a lot of time waiting for something to go wrong.
Didn't work at all.
Because, oh, okay, there we go.
All right.
Hang on, okay.
2 pings, good.
But the first one was red.
Yeah.
Does that mean the server was sending one down?
Mm-hmm.
Ah.
So every 10 seconds, the server sends a ping, and every something, the client sends a ping.
Oh, okay, I just got it. I think you said this before.
There's no pongs.
Each side is just sending messages,
Just
and
pings.
each side is just saying, if I don't see anything from the other side in a time period, I'm just going to assume that you nicked off.
Yep.
Okay.
Got it.
Got it.
All right.
Cool.
Stable. Let's try to actually use the connection now. Let's do an invocation. Boop.
Ooh.
Huh. Okay, that didn't work. So on the server side, we received the invocation, but nothing is handling it.
Okay.
Right, so the handshake happened, sending pings back and forth. We're stable now, and now we have to actually handle
So my JavaScript that I wrote is
Yep.
sending a message to say, please call this method.
Yep.
But you're just ignoring it. You're not
I'm
doing
saying,
anything with it.
cool story.
Okay, you're throwing it away.
Yeah.
Will the client fail?
No.
Oh, okay.
I mean, maybe it should, but it absolutely doesn't.
It doesn't.
It just hangs forever.
All right.
Yeah.
All right, so it feels like we're close, actually.
Yeah, this feels pretty
All
good.
right.
Just more copy and pasting, we'll be done soon. All right, so we're gonna copy these 2 types, hub message and hub message invocation, to the top of the file because that's clean. Every message in the JSON hub protocol has a type property. It tells you what type is being invoked. Type 6 is ping, type 4 is whatever, type 1 is invocation. And then an invocation message, which is type, what did it say before? Type 1, has a bunch of specific fields like the target, which is the method being invoked, the invocation ID, which is an ID so the client can correlate responses from the server side.
Right.
So I invoke with invocation 0. You send to the server side, the server wants to respond with a value. The server will say invocation 0's response is
this.
blah.
Okay.
Then arguments are a bunch of JSON arguments for the actual method you're calling on.
So we're finally at the point where we're doing the RPC bit.
Yes.
Right. Okay.
Here's RPC. Okay, and let's hustle. So here's the main loop. I'm gonna copy this code, slash it into right here. On invocation, do one more snippet. This one.
You're printing your messages twice, I think now.
Yeah?
Yeah.
Good. All right, so on receive, we find the record separator, ASCII code 30, select the byte array, get the raw hub message, deserialize into the actual one that has a type only. This is kind of inefficient, but it works. I get the type. If it's 1, then I know it's an invocation, so I do it again, but using the full message. Right? Makes sense?
I think so.
So you need to be able to parse to know what type it is. You need to know the type
You're
property.
kind of reading just enough.
So you read just the type.
I see.
You figure out if it's 1 to 6, and you
see.
parse the actual concrete type based on that number.
Got it.
Makes
Understood.
sense.
Understood.
Get the invocation, and we call it an on-invocation method. It does nothing right now. Right? And to make it do something very basic, we should actually respond with a completion response. And the completion response is in the spec, and it's type 3. And it says, here's the type 3, which is a completion, and the invocation ID, which I'm completing. And it can have an error, or it can have a result.
Okay.
But it can't have both. It's a failure.
This is the answer to my RPC call.
It's a protocol violation. Yep.
Okay.
That's right. And it can be null. If you're void and you're not returning anything, it can be null.
It's fire and forget type of thing.
Not fire and forget.
No?
No, just void.
Just void. Okay. I see. It's still a response.
It's a response, but nothing is in it, right?
I see. Got it.
So here's the invocation, and we're going to do a basic completion ACK. So I'll copy this logic into here. This is nothing. It's funny, this is actually a compile error. If you don't have a trailing comma.
Oh, wow.
What the? Holy. All right, this should make the invocation return nothing.
Nothing. Well.
So back to our protocol, test. Here's a response.
Ah, okay.
The client is happy, but nothing happened.
But I didn't get a message.
No.
Okay.
Nope. So let's make this work now.
So now we're at the point where the client was able to call like my hub method.
Yep.
But in my other example, the hub method was turning around saying clients.all.send.
Right.
But we haven't written that part yet in Go.
Right.
And so the client's like, yeah, I sent a message, but now we need to do the push part.
Correct.
The server needs to push this to all the clients.
And it's important to know that the protocol doesn't dictate the actual grouping or broadcasting or send to a client.
Okay.
It's just talking about what happens between client and server.
Right.
So I call a method on the server side. The server can decide to return a result, broadcast to everyone, broadcast to a group, not return at all.
The client doesn't know any groups
right?
or anything. It's just like I got a message. It doesn't know it was in a group due to the protocol.
Right.
Right. That's all server.
It's all server side.
Detail.
That's right. So let's make it do. So I had this thing to make it reply to one connection, but maybe we should just make it reply to both all at once. Because time is short. Go also does not have a ternary operator. You can't just in Go say like, you can't do question mark. You can't do error not equal to nil.
Right.
This doesn't work in Go.
That's unfortunate.
Come on.
Given how much you have to type that if, error, nil.
So I had to do this. This is like horrific, right?
Okay.
Let's implement reply to one connection. That's what I have as the first step.
So the first step is you're literally just going to turn around and make sure this message is sent to the person who
sent it to me.
Okay.
Right.
But it's not in the reply.
That's correct.
It's just I'm pushing another message.
This is an invocation. The same thing I sent to the server side. The client supports invocation. So I can send back the client an invocation saying, I'm going to echo your incoming method and arguments back to the client side.
Okay.
So this guy says, if target is send, I'm going to create a reply. Type 1 is invocation. Target is send. I'm calling send on the client side. I'm going to echo the same arguments I passed into the actual server side.
Okay. It's almost like echo at this point. You're really just doing an RPC echo.
So if I run this, this should echo to myself.
Oh, right? Wow, okay.
Ooh. Yeah, no claps. Tough crowd.
Were you doing that?
Tough crowd.
Were you doing that?
This isn't Go, guys.
Can you show the traffic?
Yeah.
Were you doing that? Did you send the message to the client before you sent the ACK? Or did you send it after the ACK?
Good question.
And does it matter?
Before, it doesn't matter.
It doesn't matter?
No.
Okay.
Yeah.
Because the whole thing is like asynchronous, multiplex,
all asynchronous, nothing
doesn't matter.
That's right.
Okay. So
it went to this guy, but didn't go to this other browser. Because they're not, nothing's being broadcast, right?
So you did send it to the client before you sent the client the reply from the original message.
That's right.
Because I can see it in the log. Okay.
But I can't.
Everyone get that? Did you see like the order of operations there? Okay.
Yep. But the client isn't broadcasting, so this browser isn't the same as that browser. There's no one doing a broadcast.
Each person is chatting with themselves right now. Okay. Can we make them so they can talk to each other?
That's right. This is fun chat.
Okay.
Where everyone is right.
This is like when you get shadow banned, right? In Xbox Live. You think you're talking to everyone else?
What we're going to do here is declare a concurrent dictionary equivalent in Go, which is a sync map. So I'm going to declare a thing to track the clients. Clients equals to sync.map. No. I'm going to pass it by reference because I don't want a copy of it.
Okay.
Yep. If you learn Go, you have to remember all this stuff. So use C#.
So ampersand was reference and the star was a pointer? Is that what you said?
That's right. So I need a pointer to a map. Because what could happen if I pass by a value and I mutate the object? Oh. Guess what happens?
Okay.
No one knows.
Okay.
It's a copy. It's a copy of the object, so you wouldn't have to.
You wouldn't actually.
You couldn't see it.
Okay.
Clients.store connection ID. So I'm mapping the connection ID. I'm storing the ID to the WebSocket itself, so I can have a list of WebSockets by ID.
So just a dictionary. Just think of it a dictionary.
Yep. And then
key is the ID, and then the actual connection is the value.
When it stops, I'll just clients.remove. No. Okay. Clients.delete.
Delete. Okay.
Connection ID. And then I'll pass this into the invocation. I'll pass it by reference.
Okay.
Clients. And then I'll make sure I have this be client is a pointer of sync map. And right here, the syntax is kind of weird. Get ready for your mind to be blown with a bizarre syntax. So this in Go is a cast. It looks bizarre, but it's super nice. So the value is an object. It's like an object.
Oh, you can do it in line, like left to right, rather.
Yeah. So interface is the equivalent of object. This is like an interface with anything.
Right.
And then I'm doing a cast to a WebSocket connection because I know the value is a WebSocket connection.
Got it.
And doing it this way actually lets me dot and keep casting and dotting that way. Because casting in C# requires like
wrapping and wrapping.
parentheses like this, or you can do an as and then cast.
This is because there's no generics. Like you have to pass it through as an object because you can't just say, give me
that
sync map thing of T.
Yes,
that's not a thing.
Pretty bad.
Okay.
Yeah, that's why.
Does it make you feel dirty?
Yeah.
Okay.
100%. What is it saying I can't do here?
Because you made a
Oh, this is already a pointer.
okay.
There you go. All right. So we should have a fully working application if I'm not mistaken. Oh, no, we don't yet, actually. It's good enough.
Woo! Right.
Yeah. Yeah.
Even I'm impressed. That's
Good. So we have two choices. We can make streaming work, or we could do slides and then do that.
I just want to reiterate though, like we literally took a functional ASP.NET Core SignalR app where we used the ASP.NET Core SignalR API on the server. I used the JavaScript client, and then we took the entire client part, and then you wrote a hard-coded chat server that uses the SignalR protocol in Go.
Yep.
It's not a generic SignalR server. Like if you want to go and add another hub, it's not like you just add a type and then call a map method.
Correct.
Right? You have a hard-coded server that was built specifically for this chat app, but the client just thinks it's a SignalR server.
That's right.
That's pretty cool. All right, nice.
That's what I think. I think it's cool.
You think it's cool?
I think it's cool.
Ah, well.
Is it cool?
That was pretty cool. I thought it was pretty cool.
That was fun.
All right, so you built a server in Go. Well done. So there's a bunch of stuff you didn't do.
Yeah.
Because it's just a hard-coded demo, right? But what happens if like threads occur or whatever? Like, what does that mean? It's not thread safe what you did?
So the pings are running in parallel with the actual like other code. Nothing is going to synchronize WebSocket writes.
Okay.
That should be locked.
I see. But for the sake of two clients, it turns out it's pretty safe.
Yeah.
Okay. There's no error handling, really. You had a lot of if statements, but you're not doing anything useful with them other than printing into the console. There's no grouping. So there's no, because that is very much, like I said, it's not part of the protocol. The grouping thing is just really part of our server API and our server implementation. So, I mean, you could add that, but you didn't do it. There's no client to server streaming. We could do server to
client streaming.
Server to client streaming, which would just be another for loop is my guess with a timer.
That's right.
Yeah, so that wouldn't be too hard. And there's no concept of cancellation. So in SignalR today, the protocol actually supports canceling an invocation. You didn't do that. So if the client had tried to say cancel this, the server just would have gone, all right, cool, done nothing. And then there's this frame interleaving. What does that mean? Well, if we think about the two layers going on here, we've got our transport frames, which in this case were WebSockets, right? So we have a WebSocket. Each of these orange boxes is a WebSocket frame or message, and they can be of different sizes, right? And this is per transport. They all define how they send their messages according to their spec. Then we have on top of that the hub messages or the hub frames from the hub protocol. And they don't necessarily align with the transport frames. Now this is just like you can have Ethernet frames, and then on top of that you can have TCP/IP frames, and then on top of that you can have, and I'm generalizing, so network wants, like you can come and hit me afterwards.
You're wrong.
And then you can have HTTP messages on top of that, and they don't all line up perfectly. Like things get chunked and they get correlated according to the rules of the layer. Now, it turns out that doing it from a browser makes it a little easier because WebSockets in browsers, when you call write, it pretty much guarantees it's always going to be in one frame.
Because of how we wrote the...
Because of how we wrote it, how we wrote the client.
Yes.
Okay. So you didn't have to worry about it. But as you can see, sometimes in the real world, in real implementations, they don't line up, and you have to deal with that. So for example, I could have a WebSocket transport frame which has a header with a bunch of bytes that mean things and then my actual message payload. And then I could have a JSON ping, which we saw, right? Type equals 6. And then this other message could be my non-blocking invocation message. And so like you have to deal with that in a real SignalR server. Otherwise, it'll be horribly unreliable. So what about scale out? We've done lots of talks about scale out in the past. This is a typical diagram you'll end up seeing. We have all of our clients here, and in order to support more clients, we had more servers. But then we have the problem of how does client number 1 talk to client number 4 when they're on a different server? Well, then you have to add another layer, which is the backplane, all the way on the right-hand side. And then the servers all connect to the backplane, and they can coordinate messages and send them to each other. We still support that. That's all supported today. We ship a Redis backplane implementation. I think it's the only one we ship now. Yeah, and that's all good and well. But we also have this great thing now, the Azure SignalR service, which David was a big part of architecting. And so this provides SignalR Scale-Out as a service, as a platform service. You get a subscription and your app connects to it, and then you've got Scale-Out. But it also doesn't just do the backplane part. It offloads the SignalR connections from the client out of your application. You don't have to worry about having a WebSocket endpoint in your ASP.NET Core app anymore, or your Go app. They get handled by the PaaS, by the platform as a service, okay? And then magic happens that correlates those messages back into your application. And that's fantastic for scale, because now you've got 2 scale units. You've got your web application with your MVC and your pages and your hub code, but all your WebSockets are actually connecting over on this other thing, and you can scale them independently. You're not using up HTTP connection resources on your web app. That's all being paid for and scaled separately in the Azure SignalR service. So it relays that client traffic to and from over a couple of WebSockets between your application and the service. So here's how your app starts. You've got your client that's connecting to your ASP.NET Core app. You've got web traffic going to pages or MVC views, and then you've got your WebSocket or SignalR connections going up to your hub, right? And that's all in one blue box. You can only scale the ASP.NET Core app as a unit. You can't split those 2 things apart. But then if you deploy it to Azure SignalR service, your app now connects over to the SignalR service sort of within the data center, right? Over that black 2-way arrow. That's some dedicated connections between your application on the server side and the Azure SignalR service. And then the clients sort of get split personality. They go over and connect all the WebSockets over to the client endpoint, but they happily keep doing their web traffic over to your ASP.NET Core app, which is fantastic. And then this is what it looks like when you add more clients. They're all connecting their WebSockets to the client endpoint on the Azure SignalR service. You never see them. You don't have to worry about them. It all gets taken care of by the SignalR service. And then your ASP.NET Core app connects to the server endpoint, which is private to you. And then you get an in-memory representation of all the clients currently connected to you. The SignalR code doesn't know any different. Your hub code doesn't know any different. You just say clients.all.send, and in memory it goes, yeah, I got 6 clients, send those please. And then those messages actually go over one of these pipes to the server, and then the SignalR service is the one that figures out where they go. Okay, and those clients can be connected all over the world. You just don't have to worry about it. So it completely solves an entire category of problem that is traditionally very, very difficult to solve with regards to scaling sockets, basically. All right, and then one of the things it enables is this completely new programming model, serverless. Who's using Azure Functions or AWS Lambda or something like that? Okay, so with a thing like the SignalR service, you can now build real-time or server push applications without you having an ASP.NET Core application. There's no ASP.NET in this whatsoever. There's no app I've deployed. There's no traditional SignalR server. I just have a client. In this case, it's changing an Azure storage blob. That fires an event grid event to my Azure function, which handles the event grid event, and it turns around and posts a message via the REST endpoint to the Azure SignalR service, which then broadcasts whatever my Azure function wants to all the connected SignalR clients. And there are people building apps like this today. It is actually basically officially supported by Azure Functions working in conjunction with the SignalR service. So could we build that?
No.
No?
Yes.
Okay. So do that. So we just went through the whole benefit of being able to offload your WebSocket connections onto a totally different server. Can we make that work?
So
in 4 minutes?
4 minutes. So I'll instead of doing it from scratch, I'll probably just show the code that I wrote and explain how it works, right? So I'm going to open an application that I wrote that uses.
Okay, so
here's a basic ASP.NET Core SignalR application.
Okay, this is another chat app.
Yep, a different. Actually, I want to copy. Anyway, it doesn't matter.
That's fine.
Yes, a different chat app. And the startup class looks very similar. It has this call to add Azure SignalR.
So that's the only difference.
Right.
is that my ASP.NET Core app now is saying, use SignalR, but I want you to use the Azure SignalR service.
Use the cloud.
That's it. No other difference.
Right, so I have installed the vanilla Azure SignalR SDK.
Okay.
No tricks on my sleeve, nothing crazy. I did this because of the reasons.
Okay.
I won't mention. And the chat hub is the same hub, right? 2 methods, send and stream.
Same code we saw before.
Right.
Okay.
And I wrote this, and if I look at the app settings, normally you go to the Azure portal, you would create a new Azure SignalR service, get a connection string that contains like your secret key and your like endpoint address.
Okay.
So like my app.signalr.net is your SignalR service endpoint.
Yep.
But what if I could just point to the localhost and then say port is this, right?
So you're telling the standard Azure SignalR service client where to connect.
Yeah, so point to my local SignalR service.
You're going to point to your fake one.
Right, so I wrote one in Go for fun.
For fun.
Fun and profit.
Because that's what we do.
Here it is. Here's my SignalR, my Azure SignalR server. So before I show you the code, let me run it to make sure it works. Still works. All right, build Azure SignalR, go run main.go. And then if I launch this application, it should connect to that endpoint, and it says connected. And if I launch, should I launch Chrome? Probably. So I can show you the actual thing happening. If I go to localhost 5000, which is my, I didn't copy your beautiful application.
No.
But here's the initial negotiate request to my application.
Okay.
It returned a response that said, instead of going to my application, go to the SignalR service. That's how it works.
So a negotiate request can actually respond with, this is fine, but I actually want you to negotiate over here instead. And this is how we offload those connections over to another service.
So the SignalR service gives you an access token for the SignalR endpoint you're going to hit. And mine is hosted at localhost 880.
Handwave, security.
Security, drop tokens. The URL points to the client endpoint. The server goes to the server endpoint. There's 2 endpoints on the actual Go server, my fake SignalR server. There's a documented protocol for the application to service communication that I implemented.
That's on a different GitHub repository somewhere that people can read. Okay.
And if I type test, this should work, right? Here's my actual service. And traffic is actually going to my Go application, not my main application. So if I look here, negotiate happens on the main server.
On 5000.
On 5000, comes back, goes to 8087, which is the SignalR service.
Okay.
Connects to that server directly with this giant query string.
Yep.
And then from then on, it's just SignalR business. It just sends stuff back and forth through that service.
Will 2 clients work?
That's right. That's right. Let's do that.
So now my ASP.NET Core app is still running because it served this incredibly beautiful page that you wrote.
That's right.
But then after that, it only handles the negotiate request, the first one, and then that reply is, no, go and connect your WebSocket over here. And then it doesn't really know anything until the service calls it back and says, someone hit send.
That's right.
And here's the message.
Yep.
And then the server runs and says, your server runs and says, yeah, okay, clients.send all, and then that goes back to the service and broadcasts to all the clients. Even
better, the service itself does not actually understand SignalR. It just proxies traffic from the client endpoint to the server endpoint.
Awesome.
Yep.
All right, back to the slides.
Awesome.
We are done. Back to the slides. Touch. Boop. Boop. Well, okay, so hopefully you've gotten a good indication about how SignalR works under the covers today. Hopefully you can see why the Azure SignalR service might be a benefit to you if you're trying to run this stuff in scale. Is the code available for people? Can they see
it will be.
It will be?
Yep.
By the end of today?
Yes.
Okay, well, thanks for coming along. If you've got any questions, you can reach out to both of us on Twitter, and have a great conference.
Thanks.
Cheers.